Hi again all, Professor Katsi here. I am excited to be teaching the statistical software course and leading you in an online discovery of the fundamentals of statistics and its use in social research. As you already know, statistical software is a continuation of the Research Design and Methods course. In this video, we will go over and refamiliarize ourselves with some important knowledge acquired in the research methods. These are the concepts and terminology related to research, types of research and causality, as well as review, hypotheses, and variables. In the Research Designs and Methods course, you learned the fundamentals of research in criminal justice and social sciences in general. You learned basic designs such as experimental and quasi-experimental, and methods you utilize to carry out those designs. You learn about sampling, posing hypotheses, identifying and measuring variables, problems with validity and reliability, as well as identified ethical concerns in different types of research methods. For students who are visual learners, it might be helpful to characterize the process of research methods as a diagram. In this presentation, I'll cover all concepts in more detail, but let me first show you a diagram of a model for a research process. In the beginning, you start with an interest, a theory, or an idea for which you wish to find out more. In research design courses, we may call the theory a research question. Through the process of deduction, you develop testable hypotheses. After posing hypotheses, you decide on a design and methods for research. There are a variety of methods available for research with their own strengths and weaknesses. Designs can be a true experiment, survey, field research, content analysis, etc. Then you decide on a method for data gathering or sampling. Where would you get the data? Depending on the research method, you'd collect data yourself, access data collected by others, or a combination of both. The next step would be the analysis through statistics and probability and a variety of statistical tests such as t-tests, ANOVA, chi-square, correlation, and regression. I'm sure you've heard about them. Then you conclude and report whether the hypothesis is correct or not, and through the process of induction, validate or not the theory you started with. Let's cover all of these processes and terms in more depth and refresh our memory of the overall research process. Throughout the presentation, we will see where statistics fits in this process. Let's start with review of Researchese, the language of research. By now, we should all be familiar with the language of research. Here, we will recall what some of these terms mean. There are many different definitions of theory, but in social research, the theory represents an attempt to develop plausible explanation of reality. Theory attempts to classify and organize events, to understand why and how these events occur, to explain the causes of events, and to predict the direction of future events. It represents a reasonable and informed guess as to why things are as they appear and to explain the underlying nature and meaning. Theory asks, what is the point of all of this? What does it mean? Why are things this way? While theory addresses the issue why, methodology concerns itself with what is. Methods, therefore, involve the collection of accurate facts and/or data regarding the nature of reality. Methods make the practical side of research and represents the tools needed to conduct the research, the pieces and where they fit in the design. In any field, usually exists a certain division
between those who are primarily interested in generating theory, who view their efforts as classical scholarship akin to philosophy, and those methodologists who are characterized as technical and scientific in their approach. Good social research requires both. Theory devoid of method, explanation without accurate supportive data, is just as problematic as method devoid of theory. Both theory and method should be viewed as means to an end, the end being sound knowledge. We have learned that in qualitative research, concepts are viewed as sensitizing ideas or terms that enhance our understanding, whereas in quantitative research, concepts are assigned numerical values. Statistics is mostly concerned with quantitative research, where we use numerical values and test hypotheses. Exploratory research involves research that is conducted to explore a specific problem. These specific problems may not yet be clearly defined. Exploratory research also focuses more on developing a preliminary understanding of a problem rather than conducting a full research study. Exploratory research also tends to not provide a conclusion or specific reasoning for why a problem or phenomenon occurs. Explanatory research is different because it deals with the cause and asks the question why. Explanatory research explains why certain phenomena occur or happen, while exploratory research investigates a problem that has not yet been defined. Concepts are abstract tags we put on reality and are the beginning point in all scientific ventures. They are symbolic human creations or constructs that attempt to capture the essence of reality. In deciding on a name for a phenomenon, we are attempting to describe, understand, classify, or become more sensitized to some element of reality. Examples of concepts in criminal justice studies include crime, recidivism, police patrol, etc. Age, sex, race, religion, and social class are other concepts with which we are quite familiar. Concepts generally are viewed as qualitative, sensitizing, or global notions. Operationalization defines concepts by describing how they will be measured. It can be defined in response to the statement, I measured it by. Completion of this sentence constitutes the operationalization of the concept. This process converts concepts into variables. There are different levels of measurement, which we will cover a bit later in this video. For example, you measure age using years, or you measure crime by the number of offenses occurring. A brief reminder here that deduction involves moving from a level of theory to a specific hypothesis, thus moving from more general to more specific. Sometimes this is informally called top-down approach. We might begin with thinking up a theory about our topic of interest. We then narrow that down into more specific hypotheses that we can test. We narrow down even further when we collect observations to address the hypotheses. This ultimately leads up to be able to test the hypothesis with specific data, a confirmation or not of our original theories. Induction, on the other hand, entails inferring about a whole group on the basis of knowing about a case or a few cases or a sample. Induction moves from more specific to more general. Informally, we sometimes call this a bottom-up approach. Thus, theory to fact is deduction, and fact to theory is induction. Inductive reasoning, by its very nature, is more open-ended and exploratory, especially at the beginning. Deductive reasoning is more narrow in nature and is concerned with testing or confirming hypotheses. Even though a particular study may look like it's purely deductive, for example, an experiment designed to test the hypothesized effect of a treatment on some outcome, most social research involves both inductive and deductive reasoning processes at some time in the project. In fact, you can see that these two graphs can form a cycle from theories down to observations and back up again to theories. Even in the most constrained experiment, the researchers may observe patterns in the data that lead them to develop new theories. The unit of analysis is one of the most important concepts in research projects. The unit of analysis is the major entity that you are analyzing in your study. For example, any of the following could be a unit of analysis in a study: people, groups, items or things, geographical units, or social interactions. It is called the unit of analysis because it is the analysis you do in your study that determines what the unit is. For instance, if we compare the police officers in two precincts on the number of arrests they have each made, the unit is the individual police officer because you have a number of arrests made for each officer. On the other hand, if you are comparing the two precincts on a, say, safety score for their area, the unit of analysis is the precinct as a group because we only have a unique safety score for the precinct as a whole and not for each individual officer. Now let's cover other concepts such as research types and causality. There are three basic types of questions that research projects can address: descriptive, relational or correlational, and causal study. In any research project, one of these three types is usually selected and completed. The descriptive study basically describes the subject or a phenomenon with words, numbers, tables, graphs, or all of these together. You'll mostly see descriptive studies in a qualitative type of study, and it does not really involve statistical tests, just descriptions. Sometimes it is as simple as here's the mean, the standard deviation, and here's the counts of frequency and how many people we had in each group. This can happen, for example, when you take some data from the Uniform Crime Report and just describe what is the number of offenses committed or the crime rate in particular areas, what is the percentage, cumulative percentages, the mean, median, mode, the standard deviation, the basic types of crimes committed, and things like these. This type of study does not really involve statistical tests, just descriptions. The relational or correlational study basically asks, what is the relationship between two or more variables? How are they associated? What's the strength of the association there? We would, for example, look at the relationship of police officer rates with the respective population, or with the maximum salary of police officers, etc. Generally, we find two scenarios: one where there is no relationship, and the other where there is an observed relationship in the data. First, there is the case of no relationship at all. If you know the values on one variable, but you don't know anything about the values on the other, you may see that there is no tendency in the other variable to either increase or decrease. This is represented by a measure of association value of 0. For instance, I suspect that there is no relationship between laptop sales and your grade point average. If I know your GPA, I don't have any idea how many laptops would be sold. As seen in the scatter plot here, the relationship is almost non-existent, almost 0. There is no pattern of relationship, points do not fall on a straight line, and the statistical correlation coefficient is negative 0.02, or almost 0. The other scenario is when a relationship exists, correlation is not 0. When a relationship exists, we need to determine its direction and strength. The direction means whether the relationship is positive or negative, and the strength means whether the relationship is weak or strong. We observe a positive or negative relationship. In a positive relationship, high values on one variable are associated with high values on the other, and low values on one are associated with low values on the other. For example, we assume a positive relationship between years of education and the salary one might expect to be making. On the other hand, a negative relationship implies the high values on one variable are associated with low values on the other. This is also sometimes called an inverse relationship. Here, we could hypothesize an example of years of education and criminality. The more schooling one has, the less the proclivity for criminality. These are the simplest types of relationships we might typically estimate in research. These are called linear relationships. But the pattern of relationship can be more complex than this, such as a curvilinear relationships, etc. We will be using statistical software to conduct these correlation tests, such as Pearson R coefficient, or other measures of association, such as lambda, gamma, etc. The strength of a relationship generally ranges from -1 to 1. The greater the absolute value of the coefficient of association, being that the Pearson correlation coefficient, lambda or gamma, the stronger the relationship. It is generally agreed that a correlation coefficient between 0 and 0.3 is considered weak, 0.3 to 0.5 moderate, 0.5 to 0.7 strong, and above 0.7 represents a very strong relationship. The extreme values of -1 and 1 indicate a perfectly linear relationship where a change in one variable is accompanied by a perfectly consistent change on the other. For these relationships, all of the data points fall on a line. In practice, it is extremely rare to find a perfect relationship. As we said before, a coefficient of 0 represents no linear relationship. As one variable increases, the other does not move. When the value is in between 0 and +1 or -1, there is a relationship, but the points don't all fall on a line. As the coefficient approaches -1 or +1, the strength of the relationship increases and the data points tend to fall closer to a line. Of course, the negative values represent the respective negative inverse strength. There is much more to relationship patterns, and we will explore them using statistics. Let's talk about causal or cause and effect studies. Causal or experimental studies are when a study is designed to determine whether one or more variables, example, a program or a treatment variable causes or affects one or more outcome variables. If we collected data and conducted statistical tests to determine whether a recent policy change of hiring more police officers impacted crime, we would essentially be studying whether the hiring spree, the cause, changed the crime rates, the effect. This brings us to the issue of causality. The ultimate purpose of all scientific investigation is to isolate, define, and explain the relationship between key variables in order to predict and understand the underlying nature of reality. The problem of causality has been a subject of continuing philosophical discussion, but scientific investigation is based on an assumption that the fundamental nature of reality can be known, that causation lies at the basis of reality. To approach this matter, scientific investigation entails basically three essential steps for resolving the causality problem. The first step involves the demonstration of a relationship or covariance between variables. That is, one variable is related, increases or decreases in value in some predictable manner along with increases or decreases in value of another variable. The second step consists of specifying or indicating the time sequence of the relationship, which variable is the independent variable x, and which is the outcome or dependent variable y. Generally, logic or knowledge of which variable comes first gives one the direction of causation. For example, it would make much more sense that the criminality of parents would proceed in time and possibly impact criminality in offspring rather than the other way around. The third step is the stage where many studies bog down and where research findings are subject to prolonged debate. It involves the exclusion of rival causal factors or the elimination of other variables that could conceivably explain the original relationships the researchers had claimed. The three question types can be viewed as cumulative. That is, a correlational study assumes that you can first describe, by measuring or observing, each of the variables you are trying to relate. And a causal study assumes that you can describe both the cause and effect variables, and that you can show that they are related to each other. Causal studies are probably the most demanding of the three. This was a general recollection of major concepts from research methods. Finally, let's cover other concepts, such as hypotheses and variables, which are extremely important in statistical analysis. Hypotheses are specific statements about the relationship between two or more variables and are derived from more general theories. They demonstrate an educated guess about the relationship or differences between variables in scientific research. There are three types of hypotheses: research hypotheses, null hypothesis, and alternative hypotheses. A research hypothesis states an expected relationship between variables in positive terms. An example would be the relationship between homelessness and crime. In the form of a research question, this would be stated as, are homelessness and crime related? In the form of a research hypothesis, you would state it as, I predict that homelessness and crime are related. The null hypothesis is a hypothesis of no difference or no relationship, and is the one actually tested statistically. For example, homelessness is not related to crime. Null means no effect or nothing. So it basically states that there is nothing happening between the variables. Do not confuse the null hypothesis to mean that the statement is null itself, meaning that it amounts to nothing. I guess if the term was nullifiable hypothesis, that might have caused less confusion. However, it is called null hypothesis. I think many of you might ask, why do we need this null hypothesis and what purpose does it serve? The null is an abstract, is a fictitious concept. It's our creation. What we want to know is what human nature wants to know, the difference between people or things, or whether there is a respective relationship there. So why do we create a fictional concept such as the null, which all it does is that it states that there is no difference, the opposite of what we want to know? We create this null hypothesis as a workaround to get answers about what we want to know, which we cannot get or test right away. So we create the null and test it in hopes that we reject it, because it is easier to reject the null than to find out that the research question is true. It is easier to test the null because out of all possibilities, there is only one where things are equal, where nothing is happening in this reality, and an infinity where they are different. There is only one possibility that there is no relationship at all at point 0, but an infinity between -1 and 1. And if we reject the null, it automatically means that we reject the no relationship or no difference proposition. So we accept the opposite idea that there is something happening here which we wanted to prove in the first place. The null hypothesis we used as an example before would be that homelessness is unrelated to crime, or, stated otherwise, there is no relationship between homelessness and crime. The alternative hypothesis is the hypothesis that is the opposite of null, and it is the statement that matches your research question, what you want your study to show. The alternative should complement the null, so both the null and the alternative should make up 100% of all possibilities out there. So if the null is that the new car's gas efficiency, mean miles per gallon, is 38, the alternative should be that the mean is not 38 miles per gallon. It does not matter if it's more or less. However, sometimes alternative hypotheses can be stated as directional or one-tailed. In this example, we can state that the mean is less than 38 miles per gallon. However, this does not capture the universe of possibilities where the mean miles per gallon would be greater than 38. It is advisable, however, that most of the time you should state two-tailed hypotheses. There could be a complete semester needed to explain only hypotheses. Let's talk about variables. As we mentioned before, variables are concepts that have been operationalized. A variable, then, is an entity that can take on different values. Okay, so what does that mean? Anything that can vary can be considered a variable. If something is able to vary, it is a variable or variable. For instance, age can be considered a variable because age can take different values for different people or for the same person at different times. Similarly, country can be considered a variable because a person's country can be assigned a value. Theoretically, variables can be of a qualitative nature. For example, qualitative distinction could be made regarding a person's age, old or young. The variable borough can consist of different values, such as Brooklyn, Manhattan, or the Bronx. but we can, if it is useful, assign quantitative values instead of the text values. But remember that we don't have to assign numbers in order for something to be a variable. An attribute or category is a specific value on a variable. For instance, the variable agreement might be defined as having 5 attributes. 1. Strongly disagree. 2. Disagree. 3. Neutral. 4. Agree. 5. Strongly agree. Or New York City's boroughs attributes, as we mentioned before, are Brooklyn, Manhattan, the Bronx, Queens, and Staten Island. Counties' attributes may be different. Finally, there are 2 traits of variables that should always be achieved. Each variable should be exhaustive. It should include all possible answerable responses. For instance, if the variable is religion and the only options are Protestant, Jewish, or Muslim, there are quite a few other religions I can think of that have not been included. The list doesn't exhaust all possibilities. On the other hand, if you exhaust all the possibilities with some variables, religion being included, you would simply have too many responses. The way to deal with this is to explicitly list the most common attributes and then use a general category like other to account for all remaining ones. In addition to being exhaustive, the attributes of a variable should be mutually exclusive. No respondent should be able to have 2 attributes simultaneously. Generally, this is easy, but while this might seem obvious, it is often rather tricky in practice. Variables may be measured on 4 levels: nominal, ordinal, interval, and ratio. Nominal and ordinal variables are usually called categorical variables, while interval and ratio are numerical variables. For detailed information on levels of measurements, please watch a video I have put on Blackboard and YouTube on this very topic. Now let's look at the predictor and outcome variables, more typically known as independent and dependent variables. Another important distinction having to do with the term variable is the distinction between an independent and dependent variable. This distinction is particularly relevant when you are investigating cause and effect relationships. We must learn this distinction. Let's start explaining the dependent variable, the outcome. This is the variable one is attempting to predict. By convention, it is represented by the letter Y. Common dependent variables in criminal justice are concepts such as crime, arrest, recidivism, etc. The independent variable, the predictor, is the variable that causes, determines, or precedes in time the dependent variable and is usually denoted by the letter X. An independent variable in one study could become a dependent variable in another. For example, a study of the impact of homelessness X upon crime Y finds homelessness as the independent variable, whereas a study that looks at poverty as a predictor for homelessness finds homelessness as a dependent variable Y. As a rule of thumb, the treatment variable is always an independent variable or predictor, as are demographic variables such as age, sex, and race. The dependent variable usually is a behavior or an attitude. Without a solid knowledge of variables and hypotheses, we may not be able to conduct the appropriate statistical tests in any statistical software we may use. For example, some hypotheses look at differences between groups or attributes of one variable in relation to the other, and some may look into relationships between variables. These may use different statistical tests, such as t-test, ANOVA, factorial ANOVA, chi-square, or regression, based on the type of hypothesis and type of variables. We will learn all of these as we move forward. This concludes the presentation, which summarized the general knowledge acquired in research design course and sort of introduced you to the use of statistics as the final step in social research. You can refer back to this video presentation whenever you need to clarify the meaning of any of the concepts discussed and explained here. I wish you good luck. See you soon.